Hey, what's up, guys? So this is the last section we'll do with rational expressions. This one I think you'll find a little bit easier, hopefully, than the other ones were. So we're going to start up here at the top on this little note page here. Just quickly reviewing multiplying, dividing fractions. So this first one, number one, remember if we multiply fractions, all you do is multiply straight across. Okay, so we would take the 3 times the 6 and then the 4 times the 7. Now, what you can do, if you want, you can simplify a little bit first, okay? Because if you look for anything on the top that has any factors in common with anything on the bottom, you can reduce it, okay? It's just like reducing a fraction. So with the 6 and the 4, they both have a 2 in common, so we can reduce each of those. If we divide them both by 2, that 4 becomes a 2, 6 becomes a 3. Okay? Now all I got to do, multiply across the top, so I've got 3 times 3, so that gives me 9. On the bottom, 2 times 7, 14. We're done. Okay? Alright, over the next one, dividing fractions. We're not going to really do a lot with this, but in terms of the stuff below. But I want to just show you just a refresher on it. So if we're dividing by a fraction, remember all we do is multiply by the reciprocal. So basically what this means is we're going to take 3/4 times the reciprocal of 6 over 7, which would be 7 over 6. Okay? And then I can do the same thing. I can reduce, okay? 3 and 6, a 3 goes into both of them. So I can divide them both by 3. So that 3 is going to become a 1, that 6 is going to become a 2. Okay, so when I multiply, I've got 1 times 7. On the bottom is 4 times 2, so this reduces to 7 over 8. Okay. So, now, putting these as rational expressions. In other words, basically fractions with x's involved somewhere, or some sort of variable involved. Okay, we just do the same idea. So, if we look down here, the second one, right, letter A right there. So 2x over 5 times 10 over 4x squared. So my advice is try to reduce stuff first. So if we take a look, right, and again, anything on top can reduce with anything on bottom as long as it's all multiplying here. So 2 and 4, that can reduce to 1 and 2. Okay. Now if we look on bottom, you've got 5 times 2 is 10, right? So since 5 times 2 is 10, both those can cancel out with that 10. Okay? So now if you look, all the numbers actually canceled. So all I've got left is x's. So I'm going to write what I have left just to kind of clean this up a little bit. So on top is just an x. On bottom is just the x squared. Okay? Well, x and x squared can reduce. Okay, if we basically divide each of those by x, top becomes a 1, bottom becomes an x. Just get rid of an x on the top and bottom. Okay, so that whole thing that we started with reduces down to 1 over x. Okay, let's see if I can change the color here, make this so you can see a little better. Alright, second one, alright, B, if we look again, we've got 3 on top and a 6 on bottom, so those can reduce to a 1 and a 2. Okay, because I divided both of them by 3, since 3 goes into both of them. Alright, the x's now, same deal, I can basically divide both those by an x. So the one on top cancels. The one on bottom is going to now become an x squared. So what's left here, on top, I have a 1, and then this just reduced down to another 1, so 1 times 1 is 1. On bottom, this x cubed, remember we canceled it with one of the x's, so that takes it down to x squared. And then we still had a 2 down there, so it's just 1 over 2x squared. Sorry about my handwriting here. I'm trying to write on my iPad. But it's, again, 1 over 2x squared. Okay? So, these ones over here on the right, we're actually not going to do. All you really do, though, if you had to, I'll show you just how to start it. Okay, you're not going to be assigned this stuff, but so for C here, remember we multiply by the reciprocal. So all you end up doing is flipping it over and then you do the same thing. Okay, but I'm not going to spend time having you guys do that. We're just going to worry about multiplying. So now look down in the next one below here, all right, down here. So if we take a look, it looks super complicated, right? You got all kinds of stuff. You got parentheses, x's, 2's, 6's, all kinds of stuff. All right, we're taking this first fraction times the second fraction. All right, if we do that, we can still cancel stuff from the top to the bottom as long as it's a factor. In other words, as long as it's like by itself. Okay, if we think about these all being in parentheses. So like this parentheses on top here with the x plus 2, there's another one on bottom as x plus 2, so those can cancel because they're common factors. Okay, the x minus 6's, so we look both, there's x minus 6 on top and bottom, so those can cancel. All we're left with, x plus 5. That's it. Okay, so basically just look at what groups are the same, and then you can cancel those. All right. Again, we're not going to mess with this or this, but let's look down at the bottom. This is about as hard as they get. Right now, if you look, there's not a ton you can do. The 5 and 15, those can reduce, since 5 goes into both of them, so that can go down to a 1 and a 3. Okay. The rest of it, though, we can't cancel it because it would have to be like this group would have to be the same as this. Sorry about that. Would have, so that x squared minus 10x plus 21 would have to be the same as this bottom one, which it's not. Okay, but if we look at those, you can factor those. Okay, you're not going to have to do a ton of this, but just a little bit. So rewrite what we had. Okay, I'm going to factor that x squared minus 10x plus 21. If you remember diamond problems, so the 21's on top, negative 10, or 21x squared, I guess, would be on top, negative 10x on bottom. So any numbers that multiply to 21x squared, add a negative 10x. So that looks like that's going to be negative 7x and negative 3x. Okay. Make our box. See if I can, I don't know if I'm going to be able to write small enough to be neat here, but x squared and 21, and then my two ones I found from the diamond problem. Okay, so if we go across x squared and negative 3x, both have an x in common. Means that's got to be an x up there. X, to get the top right, x times negative 3 gives me negative 3x. It's bottom one, so that's a negative 7 down here, sorry. X times negative 7 gives me that. So I factored that part, so up on top of this second fraction is now x minus 3, x minus 7. Okay. So now it's starting to look like that one before. If we can get that other one to do that and it has a common factor, then they can cancel. So we'll factor that bottom part. So I'm going to have a 9x squared on top and negative 6x on bottom. Oh no. Get this back. Okay, negative 6x on bottom. So numbers that multiply to 9 add a negative 6, so that's going to be negative 3 and negative 3, so negative 3x, negative 3x. Okay, if you notice, if there's not a number in front of x squared, you don't really have to make the box. Okay, if you look at the last one, the numbers that we got, negative 7, negative 3, that's the numbers in parentheses. Okay, all the ones you're going to be doing with this are going to be like that, so we don't really need the box. So this one we could just end up factoring to x minus 3 and x minus 3. Okay, now if we look, all right, well, what's going to cancel? I've got an x minus 3 on top. I have two of them on bottom, so I just cancel with one of them. I don't have any other common factors, so now all we do is write out my answer, and I'll just do it over here. So the numerator, all that was left, I had a 1 times x minus 7, so that's just x minus 7. Denominator, I had the 3 times x minus 3, so I just write that. And we're done. Okay. That's this section, okay? Your assignment for today, obviously, is to watch this, which you've already done if you're at this point. And then you need to send me a message on It's Learning, letting me know what questions you have, if you have questions. If you don't have questions, send me a message and let me know that you're good to go. Otherwise, that's it. Have a good day. Hope you guys are all doing well.